So in the last class, we had already discussed about these how the CSV file is included in this environment. I'm importing the CSV file using this now. Before that, I am importing this library functions, that is the NumPy and pandas. And up to this, I had already discussed in the last class, right? Then for modeling, regression model. Now, as far as I remember, that in the last class, that is ended by this modeling of linear regression. After modeling of linear regression, I am fitting the regression model. I am fitting that linear regression model. Now, when I want to fit that linear regression model, I have to use the model dot fit. Here the model name is the regressor. Regressor is basically the model. So the model is defined over here from sklearn dot linear model. I'm importing the linear regression. As I want to create the model of linear regression, therefore I am importing the model linear regression. What is my model? The linear model is linear regression. And this model is defined by as regressor. Linear regression is defined by the regressor. That is why I'm writing over here regressor is equal to linear regression. Then I'm fitting my X train and Y train into the model, and the model of linear regression is created over here as it's shown over here. So linear regression model is already created. Now, when the linear regression is created, so I have to evaluate the intercept of the model. I just write over here the model dot intercept, and I'm getting that the intercepting line. So the interception takes place at a value of 26.75. It is approximately to 26.76, and the coefficient of the regressor model is given like in the form of arrays. That is, as I'm using the NumPy array, the coefficient of the model is 3.266. That means that approximately the coefficient is 3.27. Now this is the interception and the regression and the coefficient of the regression. Now, after doing the, I have to predict the model using the X test, and I have to, that is for, as I told you in the last class, that there, for creation of the model, we use the two set. One is the training set, another is the test set. So training set is used for evaluating them, is used for building the model, and test set is used for evaluating the model. So now I have what the model I had created over here. I now have to evaluate that particular model using the X test set. So using that test set of the X value of the test set, I want to predict the model, right? So my predicted value with respect to the model is given in the form of this array, right? Now I am predicting that value. This is ypred. Ypred is basically the predicting value from the X test, and from there I'm getting the predicted value of the model from the X test, right? So that is my predicted value. These are basically my predicted value, and this is the actual value of the X test, right? So these are the basically the predicted value, and these are actual value. These are the actual value, that is the target value, and these are all predicted value of the model, right? Now I want to evaluate the model. Now, when I want to evaluate the model, I have to use from sklearn import metrics. And I have to learn print absolute error. So so for absolute score error, including that bracket y is set of y for red, so the mean absolute error is over here is 17.59. Squared error is this, and 25.67 is the root mean square error. Right. So we are calculating the mean square error. So these are the in case of evaluating the model. So 25.67, if we calculate the mean value, and we will take basically the root mean square error, not otherwise. So 17.56 is the mean absolute error. The mean square error is 65.9. We will not consider these two errors. We will consider only the root mean square error. So root mean square error is 25.67. And these are the three error calculations. Okay. Right? Any problem? So these errors are basically calculated this y test, that is the actual value, with respect to the predicted value. With respect to the actual value and the prediction value, what are the various errors are over here with my what model with respect to my model? What are the errors are calculated? Those errors are displayed over here. Right, with respect to my model which I had created over here, that is this linear regression model, with and this is my predicted value of the model, and these are the actual value of the model. With I'm comparing these two values and I'm getting these errors using this import metrics, using this library import from metrics. I'm calculating this error. What are the possible errors of my model? Right. So these are basically the errors which are calculated with respect to the predicted value and the actual value. That is, y test is the actual value and y pred is the predicted value, and I'm getting these three types of errors. Have you understood?
Yes, sir.
So this is all about what the linear regression, right? So we have completed the linear regression, right? And I will give this material to you. This material to you, right? This site stack abuse linear regression with stack scikit-learn. Right. There the linear regression, simple linear regression is given, and with coding part, all of these things are explained over here. So now we move to multiple linear. So multiple linear regression is in simple linear regression, we are considering only the one predicted value and the one target value. But in the multiple linear regression, we are considering not only the one predicted value, there may be a two or more predicted values. There are more than one predicted values, but there are one target values. So with respect to more than one predicted value and one target value, we are creating a model which is named as the multiple linear regression. The term multiple is defined for the number of more than one predicted values. With the respect of more than one predicted values and one target value, I am creating a regression model which is linear, which is also a linear regression, but it has more than one multiple predicted values, that is the multiple variables. That is why it is here, it is written in the previous section we perform linear regression involving two variables. That is, involving two variables means, there is only one uh, predicts target values and the one predicted values. But in case of multiple linear regression, there are more than one predicted values. So that is why it is said as multiple linear regression. And almost all the real world problems you are going to encounter will have more than two variables. See, there in the supervised machine learning, the in real time problem, we are dealing with this multiple linear regression, not with the simple linear regression. So all what in the supervised machine learning, the in real time problems, we are when we are considering, when as a linear, we want to establish as a linear regression model, we basically use the multiple linear regression, we implement the multiple linear regression, not the simple linear regression. The in linear regression involving the multiple variables is called multiple linear regression. That is why I'm telling that there, when there is more than one predicted values which involves the multiple variables, there the multiple variables means the number more than one predicted values and one target values. That is why it is called multiple linear regression. The steps to perform the multiple linear regression are almost similar to that of the linear regression. The difference lies in the evaluation. In the evaluating the model between simple linear regression and the multiple regression, there lies the difference. You can use it to find out which factor has the highest impact or predicted output and how different variables relate to each other. In this section, we will use a multiple linear regression to predict the gas consumption in millions of gallons in 48 US states based upon gas taxes in Sen. So here there is a data model, a data set is given over here for the gas. So this is the data set. Right. We will consider it. Uh, Now, before I proceed in this coding part, I want to say something about the multiple linear regression. Just a minute. So, in simple linear regression, we are using the two values. That is, the data set is defined by two variables. That is, suppose that is x and y. So where there is if the x is the predicted value and the y is the target value, right? But in the multiple regression model, there may be a one target values, but the number of predicted value may be many. That is, there may be x1, x2, x3, and up to xn. So these are basically the predicted values. These are the predicted values. And this is basically the target values. Target value. So with one target value and many predicted values, we want to create to develop a model which is a multiple linear regression. This is multiple linear regression. The regression is linear, but with the multiple variables, that is the multiple predicted values. Multiple linear regression, right? So in that respect, my equation will also differ. Y is equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 plus beta 3 x 3 plus dot 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 up to beta n xn, where these beta 1, beta 2 are basically the coefficient of the regression model, right? These are basically the coefficient of the regression model. Regression model. Right. So with respect to the number, this x1, x2, x3, xn are basically the predicted values with respect to the coefficient b0, beta 0, beta 1, beta 2, beta 3, and so on. Right. So this is basically the equation, the multiple linear regression equation model. Right. So this is the equation of the multiple linear regression. Understood?
Yes, sir.
Now, mm, my predicted, nothing things to remember over here that my predicted value, my predicted value, my predicted value may be close to the target value. It may be close to the target value. Just a minute. So my predicted value may be very close to the target value, or it may be uh, less or greater than the target value. My predict Another thing is that my predicted value may be 100% to the some target value, but overall prediction is not 100% in comparison to this target value, right? To this target value. So, and here also we will use matplotlib for data visualization, right, from the data set. And we will also see the various statistical analysis of the data set by using the describe function. Is it clear? What I discussed? Is it clear? Is it clear?
Yes, sir.
So this is the data set. So this is the target value and all other predicted values. So this is the target value. For multiple. import the file. It's the table is my data set is imported into this environment. Right. So df, if I want to see the string values, then we show the data present string values. These are basically the predicted values, and these are the target values. From that, if I want to see the last 10 values, df.tail, the last 10. So next time, if I want to see the statistical details, df is right. So these are the statistical details that count, mean, standard deviation, max. Now I have to prepare the data. So this just have just prepared the data. The preparing of data means I have to declare which one is in the training set and which one is the test set. That is the I'm declaring which will be my predictor variable and which one is the target variable. So target variable here is only the petrol consumption will be the target variable, and all others are the predicted variables. So petrol tax, average income, paid highways, population, driver license, these are basically my predictor variable, and my target variable is only the petrol consumption. So preparing this. We are preparing this data. Now, and I want to split this data set after preparing. So preparing of data means I am just declaring from the data set which will be my predicted value and which will be my target value. That is my preparing. Now I split this total data set into my building the model as well as testing the model. That is the training set and the test set, with taking into consideration that my test set will be 30% and the rest of this, that is 70% of, is my training set. Now the random state is also given, as I told you, that the random state is given equal to 0, or random state is used to count the stability analysis of the model. For the stabilization of the model, for the stability analysis, we use the random state, and it random state is basically stands for the 0, and because 0 is basically the 0 defined as the state the model is stable. So I will declare from the next coding part into the training set and the test set. So I will write from sklearn dot model selection import train underscore test underscore split s underscore string that x underscore so underscore train comma x underscore test comma y y underscore train comma y underscore test equal to train underscore test split and inserting x and y, taking into consideration that test size test underscore size test size is equal to Right. So my training set is x underscore train. These are my training set. And my test set is the my test set. And then my y train and the y test. These are all test set. So what is the dimension? Dimension of the training set. As I see the dimension, so I will write extreme dot shape. So 33. The dimension of y train so there are 33 columns for its y train. Okay. Now I will build the model. In order to build the model, I will use from sklearn dot linear model. Linear import import linear linear regression. Let right. So next step is to build the model. Regressor regressor equal to linear regression. Now I want to fit the training and y train and x train into the linear regression. So I'm writing regressor dot fit. I'm fitting the values into linear regression. Regressor dot fit to x train x train comma and y train. Fitting the values of the training set. See, the model is created. Understood?
Yes, sir.
Now, this model, we will calculate the coefficient of the model. So, calculate the coefficient of this model, that is the coefficient means those beta values, that is beta 1x plus beta 2x, beta 3x, beta 4x, dot 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 up to beta nx. The coefficient of those beta values we will calculate. So I will write coefficient of the df coefficient underscore df underscore equal to d dot d dot data frame is the dot coefficient dot column dot columns of the coefficient. So, I know C E coefficient of this multiple regression. So these are the coefficient of the multiple regression. That is, these are basically the predictor values, and this is all the beta values, with corresponding to the predicted values. So these are x1, x2, x3, x4, and these are beta 1, beta 2, beta 3, and beta 4. With x1, the corresponding coefficient is this. With x2, the corresponding coefficient is this. x3, the corresponding coefficient is this. x4, the corresponding coefficient is this. That is, I am getting the values of so I am getting the values of y is equal to beta naught plus beta 1x plus beta 2x plus beta 3x and plus dot 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 up to beta nx. So I'm getting these values. So these values I am getting. So these are basically the coefficients with respect to the values of x1, x2, and x3. That is, with respect to these predictor variables, I am getting the values of the coefficient. Right. So these are the coefficient values. Right. So what will be the intercept? So the intercept values, I will write model, that is the tracer dot intercept intercept. So I'm getting the intercept value. Right. So this is the coefficient value of the model, and this is the intercept value of the model with respect to y-axis. The interception value is 470.36. Right. Understood this thing? Have you understood?
Yes, sir.
Now I will use the predicted value. So I will write y underscore spread equal to the model is the regressor dot dot spread predict predict, and I'm using the x test. X underscore x test. So uh, what will be my predicted value? Let's see y my predicted values by grade. So these are the predicted values of my by creation of the model with respect to the target values. These are my predicted values. This is the predicted value of the model with respect to the target values. So if I want to see the data frame, so we will write EF is equal to PD dot data frame if I want to see the predicted value with respect to the actual value. So I'm writing actual actual. The actual values are basically the white and importantly I'm inserting the test value x test and make it as white red. With respect to x test, I'm making as the white red. Now I'm using the actual value. So the actual value is equal to y test y underscore the testing value, y test, and so this is a target variable. So the target variable is basically the y test value, and the predicted value which are x test, these are basically the predicted value. X test is basically the predicted value, and y test is the actual value. The y test, comma, predicted value value of y underscore red, y underscore red. If I want to see the data frame, I will see the actual and the predicted value. See, these are the actual and these are predicted values. The actual value is 534 and the predicted value with respect to the model is 468.312. You can see maybe 33312. So now how much error has been created? Right. So if I see from skill earned, import, metrics, then import, non-import. Okay, I will want to create the want to calculate those errors for the mean value because without error I don't know how much the model is accurate or not. So mean absolute error, mean absolute error, metrics, metrics underscore absolute metrics dot mean underscore absolute for error. How much error is created with the predicted value and the y test. So we will write y test, y red by red. So these are the errors. 49.03 mean square is the square value of this. So mean square and root mean square is 60. Root mean square is 60. Now the if we calculate the mean value, so with respect to y test and the predicted value, with respect to the predicted value and the actual value. So y test is the actual value, y pred is the predicted value. with respect to the actual value and to the predicted value, the corresponding errors are given. That is the for the absolute error is 49.20. Mean square error is basically the square of this thing, that is the 36 73 point 3673.20, and the root mean square is 60.60. Right. So these errors are calculated with respect to the test value and to the predicted value. Right. So root mean square is basically the square of the square root of the mean square value. Right. So mean square value, that is the root mean square. And the mean squared value is the deviation between the actual value and the mean actual value and the predicted value, taking summation of the whole thing, and taking the summation of the whole thing with respect to the modulus. So with respect to the modulus and to the mean and to the mean and to the actual and the predicted value, that is the difference between the actual and the predicted value, gives and the total summation of the actual and the predicted value, the with respect to the mod value, is given by the absolute error, and the square root of the absolute error is the mean square is the square of this absolute error, and that is why it is given the double figure, the 3673, because it gives the square of the absolute value. So, and the root mean square is the square root of the mean square value. Now, so 60.60 and the actual value is so 60. So this is 25.67, which means square value. So how much it is accurate? If we calculate it as 25.67, sorry, 60.60. So if I say 60.60 divide by the actual values given 534, right? So divide by 534 into 100. So it gives near about 11.3, which is near to the 12%. So the error is greater than 10%. So my accuracy is more than, that is not, it is not greater than, it is greater than 10%. So my accuracy is giving the 11.3, which is 11%. That means the accuracy is 89%. The model is accurate with 89% is the model is accurate. So although the algorithm which was developed over here, the model which was developed here is not so very much accurate, but still it gives a very good, reasonable predictions. So the prediction is far better, and there is no problem. Understood?
Yes, sir.
So any problem you can ask. Any problem?
No, sir.
So this is all about what is multiple linear regression, right? So next day, that is on Friday, we will go to the logistic regression. We will go to the logistic regression. Shiny Vishal, any problem? Any problem, Shiny Vishal? Shubham Sarkar? Any problem? Sima Carnival?
No, sir, no problem.
Okay. So in the next class, we will move to the logistic regression, right? That is the classification problem. After that,
Okay, sir.
from the logistic regression, we will move to the KNN, K nearest neighbor, and then random forest and decision tree. All are basically from logistic regression. These are basically all the classification problem, right? That is, we will deal with the discretized function, discrete function. On regression is a continuous function, but in case of the classification problem, we will deal with the discrete functions. Okay, so on Friday, we will move to the logistic regression. Okay.
Santanu, I'm stopping the recording. Okay.
Okay.
Sir, do we have